Welcome back to Infinity Beyond, where we explore the uncharted frontiers of space with curiosity and wonder. In our last journey, we examined the frozen moons of the solar system, Europa, Titan, and Enceladus, each one offering tantalizing hints about the potential for life in the cold. But now, it's time to journey even farther, beyond the planets, beyond the stars, into the coldest, loneliest places of all, where rogue planets drift in the eternal darkness between solar systems. Let's begin with a question that might sound strange at first. What happens to a planet when it loses its star? Rogue planets, also called interstellar planets or nomad worlds, are planetary mass objects that don't orbit a star. They float freely through the galaxy, unbound by any solar system. Some may have formed like stars, but failed to ignite fusion. Others might have been violently ejected from their home systems during chaotic periods of formation. Imagine a gas giant the size of Jupiter, wandering the void alone. No sunrise, no warmth, no orbit. Just a slow, endless drift through the cosmic night. These are the coldest of the cold, the loneliest travelers in the universe. What's most fascinating is that these rogue planets might not be as rare as we once thought. In fact, some astronomers estimate there could be more rogue planets in the Milky Way than stars, billions of them, hiding in the black between systems, invisible to our telescopes, unless they happen to pass in front of a distant star and reveal their presence through gravitational lensing. The study of rogue planets is still in its infancy, but already we've found some tantalizing candidates. One of the best known is Ogle 2016 BLG 1928, detected through gravitational microlensing. It's believed to be a free-floating Earth mass planet located thousands of light-years away. A tiny world, all alone. But even gas giants can go rogue. PSO J319.522 is a rogue planet about 80 light-years away. It's estimated to be around 6 times the mass of Jupiter, and emits a faint glow from leftover formation heat, despite having no host star. In its youth, it may have supported a thick atmosphere or even weather systems similar to those on brown dwarfs. You might wonder, how could anything survive on such worlds? Wouldn't they be frozen solid, lifeless rocks, or balls of gas perhaps? But nature is nothing if not surprising. Some scientists speculate that if a rogue planet had a thick atmosphere of hydrogen and sufficient geothermal heat, it could maintain a habitable subsurface ocean even in the absence of sunlight. Beneath miles of ice, internal heat from radioactive decay or core convection might create a warm enough layer for water to exist in liquid form, like a planetary thermos sealed from the cosmos. It's a strange idea, life thriving on a planet without a star. But if moons like Europa and Enceladus can harbor oceans beneath their ice, why not a rogue planet with enough internal heat? And if life doesn't exist there, perhaps the building blocks do. Organic chemistry isn't picky about sunlight. It just needs energy and the right ingredients. Let's shift gears now and consider another class of frozen worlds. Ice giants. We're familiar with 2 in our solar system, Uranus and Neptune. Unlike gas giants like Jupiter and Saturn, ice giants are composed mostly of elements heavier than hydrogen and helium. Things like water, ammonia, and methane. Their icy mantles are buried beneath thick atmospheres, hiding strange and extreme conditions. Uranus, for instance, rotates on its side. Its axial tilt is over 90 degrees, which means its poles experience 42 years of continuous sunlight followed by 42 years of darkness. Its atmosphere is the coldest in the solar system, with minimum temperatures dipping to 224 degrees C. Yet deep inside, it may harbor exotic forms of water under immense pressure, perhaps even an ocean of ionic water where molecules are stripped of their electrons. Neptune, farther out, is a tempestuous world with supersonic winds, dynamic storms, and a bluish atmosphere rich in methane. It too likely contains layers of compressed ice and liquid, possibly with diamond rains falling through its mantle. Now imagine these kinds of worlds scattered throughout the galaxy, not orbiting stars, but floating freely. Frozen gas giants, ice-coated super-Earths. Some might have moons. Some might have atmospheres that glow faintly in infrared. Others might be completely inert, silent, frozen relics of failed systems. There's even speculation that our solar system might once have ejected its own rogue planet. Some models suggest a fifth giant planet was flung out during the early days of planetary migration. If so, that orphan still drifts out there, untethered and unknown. What do rogue planets and ice giants teach us? That the universe is chaotic, that not all planets follow neat orbits, and that even in the coldest places, fascinating processes are at work. Chemistry, gravity, energy, and maybe, just maybe, life. They also teach us humility. Earth, with its perfect distance from the sun, its protective magnetosphere, and stable climate, is a rare jewel. But it's also part of a vast cosmic story. A story that includes lonely wanderers, frozen titans, and the whispers of ancient collisions. So, as you drift off tonight, picture one of those rogue planets. Cold, dark, silent, but not forgotten. Somewhere in the galaxy, it waits for discovery, for meaning, for light. In our next segment, we'll journey to the edges of cosmic background radiation and explore the faint afterglow of the Big Bang, the coldest signal in all the universe, a signal that tells the story of everything. Until then, keep wondering,